So welcome back. During last lecture, we were talking about the pyroclastic flows, and as I told that this fragments, okay, depending on the size of the fragments, we say that okay, either it is ash or it is the lapilli or it is bomb, okay, and all are termed as the pyroclastic flow, and so just to get started with, we will see that okay, fine, this smallest size material which is coming out through the volcanic during the volcanic eruption, less than 4 mm is clay size, are termed as ash, and then we are having slightly larger which are lapilli, and the biggest one which we talk as in bombs, which are greater than 32 mm. Okay. So pyroclastic texture, or the rocks which we see, which are seen during the time of eruption which is coming out, we have the ground mass which has been termed as ash, okay, finer ones, and then we are having the lapilli and all that, okay, and the larger pyroclasts are known as volcanic bombs, okay, and typical shape within head and tail will be seen, okay, and bomb can result into severe damage if they strike, okay. So these are the very typical shape we will see, which is greater than 32 mm, and they have the tail and the head, and so definitely if this type of rock fragment is coming out and hitting somewhere, will result into the damage, okay. So these are extremely dangerous in terms of the hazard, okay. So we say that okay, fine, we are fortunate that we are not having such type of violent volcanoes along the Indian subduction zones, okay, we are having, so we don't have such volcanoes. Of course, we have an active volcano along the Andaman arc, which is known as Barren Island, but it is not very violent as we have been talking about of different volcanoes around the world, okay. So few famous monuments. So I just wanted to complete this lecture showing some of the monuments which have been made or which are located where used or been built using the igneous rocks mainly, okay. So if you look at the famous monument, this one is famous Mount Rushmore, okay, which is in US, which has been built on the granite, okay, is mostly the granite, and the structure or the form of this is batholith, okay. So this is one of the batholith comprised of granite where this famous monument has been constructed, okay. So the carving of the faces of 4 US presidents here, okay. Then we are having so you can read out this, who are those actually, okay. And then we are having Moai statues carved from basalt, okay. This is in Chile and South America, and then this is again Machu Picchu, a city of Andes Mountain, Peru, which was built in AD 1460 and 1470, and most of the structure has been comprised or built from granite. Then we are having the Thanjavur Big Temple, world's first granite temple, and then we are having pyramids, and then we are having Mahabalipuram, the granite, again the temple, most of the carving was been done using granite here, okay. So I end this here, and then I will start with the another lecture of looking at the different type of sedimentary rocks mainly, okay. So we'll see that how different type of sedimentary rocks are formed, where they are formed, okay, and how to identify this type of rocks, okay, and as we have seen in terms of the igneous rocks, okay. So the sedimentary rocks is most of the very large area on the earth crust is occupied by the sedimentary rocks, okay. So where we find the sedimentary rocks is mostly in the uplands, okay, in the plain areas, that is alluvial plains, and then in the ocean, okay. And usually what we see is that the sedimentary rocks will be seen deposited in layers, okay. So we are having older layers, younger layers, and then so on, okay. So we have the marine deposits, we have what we call fluvial deposits. Okay. So, let us move ahead and see that what we are having, and then of course, we are also having the aeolian deposits, and then we can see, we can talk about that there are glacial deposits also. Okay. So, if you look at different environments where you will find the sedimentary rocks, one is the glacial environment you are having. Okay. So, you are having the glacial environment one, then here you will have the different type of environments which are on the land here. So, we can have either the lake environment, or we can say the fluvial environment, or we can say the aeolian environment. So, we are having different environments which are related to this, and then we can see most of the different type of rocks, of sedimentary rocks in different environments, and finally what we are having here is your marine environment. Okay. So, this figure, it explains that the different type of environments which are related to the fluvial system. Okay. And then you are having different type of environments, either it is shallow marine or the deeper marine environments. Okay. Or it is an estuarine environment that is related to the coastal regions, and then we are having glacial, and those are in the higher mountain ranges. Okay. At the foothill zones you will find the alluvial fans. Okay. So, you are having different environment there, and then of course, you see an desert area where we see mostly the aeolian deposits or the aeolian environment. Okay. So, sedimentary rocks mainly. So, stages of the formation of the sedimentary rocks, if you look at, then what we see is that there are different stages. So, first is the weathering. Okay. So, as we have seen that volcanic rocks comes to the surface, and of course, those rocks will be subjected to weathering either by the rain or the agency of then is either the water or glacial or wind. Okay. So, they are subjected to weathering. So, physical or chemical weathering will take place, and then we are having transportation by the agents like water, wind, ice, or the gravity. Mode of transportation is either rolling or suspension. So, either they are been draped out or rolled out on the surface, they are transported in suspension water or in form of solution. Okay. Then a deposition where it will take place on land, that is continent, in transitional zone, estuaries and deltas, or in ocean, marine deposit mainly. So, if you look at this one, what we were looking at. Okay. So, we will be able to, you will be able to understand that what we see. Okay. So, from here we are having the erosion, and then we are having transportation through this. Of course, the deposition will take place, and then we are having the deposition over here, that is in the marine environment. Okay. And then finally, we are having solidification, that what we call the lithification, cementation, and diagenesis. Diagenesis is alteration of one mineral to another mineral. Okay. So, recalling the rock cycle, if you look at, so we talked about the igneous rocks coming right up to the surface through interior of earth in form of through volcanic eruptions in form of magmas and all that. Then those are subjected to those rocks. So, we have talked about the different type of rocks, either granite, rhyolite, andesite, diorite, and basalt, gabbro, different type of, either they are intrusive rocks or extruded rocks. They will be subjected to weathering. Okay. And weathering will further, you will have transportation, you will have deposition, and you will have lithification or cementation, resulting into the formation of volcanic rocks here again. So, up to this we will talk in this lecture that how different type of sedimentary rocks are formed and what are the different type of sedimentary rocks. Okay. So, sedimentary rocks are the secondary rocks, because the primary rocks are your volcanic rocks. Okay. So, these are the secondary rocks which are formed from the loose fragments or detrital. Okay, or the smaller class. Okay, of sediments produced by weathering of older rocks. Okay. Almost 90% of earth crust is made up of igneous rocks, and 75% of land surface. Okay. So, surface on the earth is covered by thin veneer of sediments or sedimentary rocks. These sediments are transported and deposited by river, water, or by wind, or by the movement of glacial ice. Okay. So, these are the agents which will transport the deposit. Of course, the transportation is also along due to the wind action. Okay. So either transportation is either in suspension or in form of solution. So when settled down after the deposition, it will undergo cementation or compaction, resulting into the formation of different type of sedimentary rocks. Of course, here also the mineral composition is important, and the nature or the process of formation is extremely important for the different type of sedimentary rocks. Okay. So the concept that was been given by James Sutton long back, okay, that most of the geological processes happen very slow in nature. Okay. So he proposed the principle of uniformitism. So he suggested that all the processes are very slow in nature. Okay. And this means that the geological processes that we observe operating today are the same processes that operated in the past. Okay. So he wanted to compare that whatever the processes we see today happened in the past also. Okay. So it was the uniformitism. Okay. So the processes are uniform and remain uniform in the past also. So that's what he termed as the present is the key to the past. Okay. So if you understand the present process, you will go back into the ancient period or the time or geological time scale and try to understand how those rocks were formed, how the landforms were formed, and how the erosion resulted into the formation or the erosion resulted into the different type of sediments which were been generated, or the classic or the detritus. Okay. So the importance of the sedimentary rocks, present is the key to the past. Okay. Helps in knowing the depositional environment. Okay. This is very important. Okay. And then either the depositional environment is a marine ocean deposit, or it is fluvial deposits, or it is aeolian deposit, or the glacial, estuarine, lacustrine. Now why it is important, when you look at some areas, like for example in Himalayas we see marine deposits. Okay, from where it came, because right now we don't have any ocean in that area. Okay, and based on the fossil contents and all that, geologists and paleontologists, they have identified that the Himalayan rocks, some of the Himalayan rocks are rich in marine deposits. Okay, so how those marine deposits came? So we can go back into the history and try to identify. If we understand the present process, we can get back into the history of the formation of different rocks and understand the depositional environments, or the formation of those rocks, how they were formed. Either they were in the fluvial, that is riverine environment, or they were in the glacial environment, or near the estuaries and all that. Okay. So it is important to understand the present process to understand the past. Okay. So it helps in knowing the provenance, from where, that is this, from the sediment scheme, that is the source or the area of the sediments, and then change in the climatic conditions, that is in knowing and understanding old climate. Okay, that is what we call the ancient climate or paleoclimate. Okay, so that helps also in understanding that what was the climate during that period. Okay, so that is again a very important part. So type of sedimentary rocks, if you look at, we are having clastic, we are having in clastic we are having sandstone, conglomerates, breccias, shale and mudstone, and then we are having inorganic or organic rocks, which are evaporites or evaporitic rocks. These rocks are formed due to evaporation of saline water, mainly the sea water, and the examples are gypsum and halite, which is also termed as rock crust salt. And then we are having the carbonate rocks, mostly comprised of calcium carbonate. Both are formed chemically by chemical leaching and by organic sources. Okay, so we are having biochemical rocks also. The example is limestone and dolomites. Okay, so you can say that this is the process where mostly you will be able to see in the marine environment. Okay, and then we are having organic rocks, of course, formed due to decomposition of organic remains under high temperature and pressure. Example is coal and lignite. Okay, so we have clastic rocks and inorganic and organic rocks. If you like to see the different type of sedimentary rocks. Okay, so these are the examples of inorganic rocks, which are comprised mostly of the minerals, which are formed due to precipitation. So you have gypsum, halite, hematite, limonite, calcite crystals, dolomites, and then we are having microcrystalline quartz, okay, which are also termed as chert. So this is because of the formation of the or we can classify this as an inorganic chemically rocks formed due to chemical processes, okay. Then we are having clastic rocks, mainly will have the grains or the fragments, okay. So they are formed by the broken rock fragments, either by weathering, erosion, this we have talked about. These are the different agents by which you will have the formation of the clastic material, okay. And then solidifies, cementation, and then we say it is in clastic rock. Clastic rocks are classified on the basis of grain size, okay. So conglomerate sandstone shale, so we are having larger grain size here, then it reduces and becomes finer up to the clay size. We will see the grain size, that based on the grain size how they are been classified, okay. So if you look, then we are having the detrital rocks. So when we are having the chemical, clastic, and then we are having detrital rocks. So this were this we are talking about the chemical rocks, and then we are having the clastic rocks mainly, okay. So detrital comprise mostly of the pieces of pre-existing rocks, okay. So though you will find within those rocks you will find some fragments of the old rocks. You may have some igneous rock fragments, or maybe you can have the metamorphic rock fragments and all that. So we are having like what we call lithic sandstone, then we are having clay minerals, clay sandstone, then we are having quartz and all that. So we have quartz conglomerates mostly, and then we are having some of the feldspars here, so we can say argillaceous rocks or the fill. And then we are having another one is organic or biochemical rocks, okay. And these are mostly you will find the marine organisms here, or the fossils, okay, which are comprised like skeleton limestone, we can term shales. Then we are having plant fragments which are rich in that, we also term that as peat. And then we are having carbon rich is coal actually. So these are again another set of rocks, sedimentary rocks, which are organic in nature, okay. Now based on the grain size, if you look at, then we see grain size which is having the in mm, if you look at greater than 2 to 256 mm, we term that as a gravel, okay. And then we are having sand, which is ranging in size from 2 to 0.062 mm, and then we are having silt, which ranges in size between 0.062 to 0.004 mm, and then we are having clay, which is less than 0.004 mm, okay. So most fine one, okay. So grain size based on this, if we are having like boulders greater than, then we can say that it is greater than 256 mm, cobbles 64 to 256 mm, then pebble from 64 to 4 mm, and the granules from 4 to 2 mm, and fine gravels, okay. So these are all been categorized in gravel, okay. So you have gravel here, so different, even if you can have the boulders, you can say that because the size is ranging here, okay, for the gravel. There is another scale which has been given in 5, and this is a logarithmic scale which has been used to compare the grain size of from the finer to coarser, ranging from clay to rise up to the boulder, okay. And these are the different type of rocks, sedimentary rocks, which have been termed or categorized based on the grain size we are having, okay. So we are having coarser ones, then we are having the gravels, then we are having the comparatively finer, then we are having sand or sandstone here, whereas we are having quartzites and conglomerate and rudaceous, and then we are having finer ones which are made up of silt or clay, and we are having mudstone, siltstone, etc. This is again the similar one which you can refer, which talks about the different phi scale and the grain size here in millimeter we are having, and then different type of rocks we are having here, okay, or this is the grain size basically, okay. So based on this we can say either this is a coarse grain sandstone or a medium grain sandstone or fine grain sandstone and all that. Okay. So, this is the grain size which has been given, which is important for classifying the rocks and saying that whether it is gravely rich or the or rocks, or it is sand rich rock, or it is finer, which is a mudstone or siltstone here. So, then another one is first is the you can use the that what is the it comprises the chemical composition also can be used. Then we are talking about the size, then we are talking about the shape of the grains. So, based on the shape of the grains also you can classify the rocks, and you can understand that how far they were been deposited, okay, from the source, okay, that the sediments were carried far away from the source, or they were been having the shorter distance transport. Okay. So, based on the shape we can talk about that whether it is angular, subangular, subrounded, rounded or well rounded. Okay. So, this is again the classification which has been given in terms of the grain size, grain shape. Here we are having angular grain shape, we are having rounded, and we are having well rounded. Okay. So, we can also say this as an sub-rounded, okay, but this is well rounded one. Okay. So, angular reflects less distance transport. So, this you can easily make out looking to the in the end specimen different type of sedimentary rocks. You can if you are having angular fragments within it, then you can say that these are the deposits which reflects less distance transport. Then sub-rounded far distance transport, and rounded very far distance transport. Okay. Again this will show the aberrations when the grains are transported. They are transported in bulk, okay, and rubbing to each other there will be the breaking and the shaping up of the different rocks, which we call during the time of. So, abrasion will take place during the transportation, which will also, so longer time if you put two different grains, then it will have the more rounded shape. Okay. Hence, rounded will indicate long distance transport. Okay. Then we are having, like for example, this is what we call the pterogenous rocks. Clastic rocks mainly comprise of broken fragments of older rocks. They are termed as pterogenous rocks. So, we are having different clasts here, and then we are having matrix and all that. Okay. So, but we have the class of different type of rocks here. So, mainly any rock fragments having the size which is greater than that, those we are termed as pebbles greater than 4 mm, and then we are having the finer granules which are less than 4 mm, and we are having matrix, okay, which are the fine grained material which surrounds the larger class. Okay. And then we are having the cements, okay, which is dissolved substance which bounds the. So, this is what we will have within one pterogenous rocks. Okay. Then we are having conglomerate, which is comprised of clastic fragments cemented within the ground mass. Okay. So, we will have all the pebbles and cobbles within that. You can term that as a conglomerate, and mostly the grain size or the grain shape will be rounded to sub-rounded. If you are having angular clast, okay, and which are concentrated in the ground mass, they are termed as breccias. Okay. So, they are very much similar, but only the shape is different. So, these are breccias are angular in having angular fragments of different rocks, whereas these are having the rounded clast, okay, that is conglomerate. So, based on the rounding also again we can say that we can sort out the different type of rocks, and we say the sorting of the different type of rocks. Either they are very well sorted, moderately sorted. Again they will talk about the transportation. Okay. So, sorting of the sediments also suggests the mode of deposition and transportation. So, long distance transport will have well sorted, well rounded and well sorted material, okay, or the clast, whereas the short distance transport will be poorly sorted and angular in shape. Okay. So, this also sorting of the material also helps us in identifying the deposition and the transportation mode. Okay. So, this is again important, another criteria which has been used, which helps in knowing also the energy condition far distance transport will have well rounded and well sorted material, where short distance transport, so the river is incapable of transporting the material, or any other agency which we were talking, they were not capable in transporting the material. So we'll see the poorly sorted and angular deposits. Okay. So there's one of the example which talks about the section. If you look at from the bottom to top, okay, it has different grain size. If you look at here, you have different grain size which comprises of subrounded clast, okay, and then we are having the finer ones here, and then we are having again, this is what we call moderately sorted, poorly sorted here, again they are poorly sorted, then we are getting in finer deposits here, then started getting coarser one, and then again you are having the coarser deposits here along with the matrix. Okay. So sorting means sediments in terms of various size. So poorly sorted mixtures of wide range of the particle size. Okay. So in terms of we can take the well sorted, most of the clasts are of same size. Okay. Whereas here you will have wide range of particle size in terms of the poorly sorted material. And then we are having the deposits. Okay. The change in the grain size typically results from the fluctuation in the velocity of transporting agent. Okay. Either it is wind or water. So if you are having fluctuation of the energy conditions or the velocity, you will have that will affect the sorting of different deposits. Okay. So either the deposits are been termed as poorly sorted or well sorted. Okay. Then if the energy conditions are high, larger or the heavier particles will be transported. Okay. The lighter particles will be carried for longer distance, even if the energy or the carrying capacity is of the agent reduces. Okay. So we will find that most of the time that we have finer deposits which are seen in the plain areas, the alluvial plain areas, where the rivers are incapable of carrying the coarser bed loads. Okay. But the finer ones will be transported right up to the mouth of the rivers, and that goes up to in the ocean also. Okay. So about the mode of transportation, till deposition. Okay. The till deposition is a term which has been given, which is comprised of angular and variable size of sediments. Okay. And are deposited by movement of glacial ice. Okay. So the glacial deposits mostly which is comprising the angular and variable size of sediments are termed as till deposits. Okay. Then rounded to well rounded sediments and well sorted are transported by water and wind. Okay. So one can easily differentiate if you are having more variable size sediments and they are angular in shape. So you can say that probably it represents the glacial environments. Of course, it is again a short distance transport. Okay. It is not a very long distance transport. So mostly the wind and water will have the capability of transporting the sediments for longer distance. Okay. So hence we see in fluvial and aeolian deposits, we see well rounded and well sorted deposits at many places. Okay. And then different type of the categories of clastic rocks, mainly if you take, we term those as Rudaceous rocks, which are made up of rounded to sub-rounded pebbles. Okay. And cobbles. So size ranges from 4 to 256 mm. Example is conglomerate. And then coming to the next stage, there is finer one little bit, which ranges in size of 0.02 to 0.062 to 2 mm. Examples are sandstone, and they are mainly comprised of sand, which are termed as arenaceous rocks. Okay. And then finer ones which are comprised of clay less than 0.004 mm are termed as argillaceous rocks, and this type of rocks are mostly the shale or mudstone or siltstone. They are fine grained rocks. So we are having Rudaceous are the coarse grain, rounded to sub-rounded material, arenaceous rocks mainly sand, and then argillaceous, which are fine grained sedimentary rocks, mostly comprised of clay site sediments. Okay. So these are based on the different category of clastic rocks. We are having Rudaceous, arenaceous and argillaceous. So, these are the Rudaceous rocks which we are having the conglomerate. Okay. And now importance of this, if you take, okay, now what we are having the mixture here is we are having the rounded to sub-rounded fragments within the conglomerate and surrounded by matrix here. Okay. So, so we can continue this in the next lecture, okay, and then we will talk more about the different type of rocks. Thank you so much.